Okay, so today we're going to continue with our notes for section 8, and I also provided you guys notes for section 9 in the Canvas because I'm gonna go into that a little bit. So after I complete this section 8, I'll give you guys a few minutes to go ahead and print out your notes for section 8. I think that'll be useful for you just to have them. But that will come in just a little bit. So let's go ahead and do these problems. I'm going to start off with number 32, and then I'll do 31 for you, okay? And since we're going to be writing them in radian, so let's see how this goes. So the first thing that we need to do is this should be in parentheses, right? So we know that it's tangent of 3x as the angle plus 1 is equal to 0. So then what's going to happen is I'm going to go tangent of 3x is equal to negative 1. And then what I'm going to do is I'm going to do a little substitution, okay? Instead of using 3x, I'm going to just go, all right, it's going to be tangent of theta. So I'm saying that theta is my 3x, okay? So it's a substitution that I'm doing. So now tangent of theta is equal to negative 1. When does that happen? When is tangent negative 1? Anybody? Okay. So it's going to happen at 2 places, right? So I'll draw the coordinate system. So remember, it's all students take calculus, and all students take calculus means that tangent is positive in the first and in the third quadrant. But we don't want it to be positive, we want it to be negative. So that tells me that it's going to be at this spot and at this spot. And so that's at 3 pi over 4, and this is going to be at 7 pi over 4, correct? So having those 2 positions then, I'm going to be able to say, all right, 3x is equal to, I'll go 3 pi over 4 plus, and how often does it become negative 1? If we look at this rotation, and it's important, I'll do it in a different color just so we can see. So if I start here at 3 pi over 4, to get to this point over here, how much of a rotation did I do to get there? Did I do a full circle rotation, a half circle rotation? What did I do? Yeah, Maria, you're right. So it's only a half circle rotation or a pi k rotation, right? Because in this problem we need to do the pi k because we do not have a restriction on our domain. Sorry, I couldn't think for a second. Now we don't want 3x. We want to find x, correct? So in order to do that, what we have to do is we're going to have to divide both sides by 3. And so that's going to give me x is equal to, doesn't that become pi over 4? Does everyone see how that's pi over 4? Or would you like me to show how that becomes pi over 4? You want me to show it? Okay, I'll show it. That's no problem. Okay. So when I divide by that 3, isn't that the same as dividing by 3 over 1? So what's going to end up happening is I'm going to go 3 pi over 4 plus pi k, and then that's going to multiply with the reciprocal of 3 over 1. It's going to become 1 over 3. And so x is going to be equal to 3 pi over 12 plus pi k over 3. We okay with that? Okay. Then from there, the 3 and the 12 can be reduced. So I'm going to get x is equal to pi over 4 plus pi over 3k. And this is my solution. So, quick question for you guys. When do I use the k pi or 2k pi, or when do I add that to my answers? When it repeats. Well, yes, when it repeats, that's true. But when we do it when they're looking for this, and this is the specific thing when they say find all solutions. So all solutions here, and all solutions with no domain restriction. So let me show you one that only had 2 answers. Let me go back up. So if you see number 23, see how I underlined from 0 to 2 pi? That restricts it. If we don't have a restriction, it's always going to repeat. Does that make sense, Karen? Okay. So that's when if they don't give us a restriction, then we need to use the k pi or 2k pi or whatever it is that's going to repeat it. So now let's do this problem, number 31. Let's see if you guys can help me do this. So 2 cosine of 4x, and that should be in parentheses, right? Plus radical 3 is equal to 0. So 2 cosine of 4x is equal to a negative radical 3. So cosine of 4x is equal to negative radical 3 over 2, right? And then I'm going to do my substitution now. And the reason I do the substitution here is because I know cosine of negative radical 3 over 2, right? And the rules to break down 4x in terms of the rules that we had are not simple. So, you know, the identities that we've used in the past, they're not simple to use here. And so we do a substitution instead. So can you guys tell me where cosine is a negative radical 3 over 2? At 5 pi over 6. Okay. Now, it's negative, so it's got to be, so again, all students take calculus. So the first and the fourth quadrant are positive, and the third and the fourth are negative. So it's going to be here, but it's also going to be here, right? And so this is going to occur at 5 pi over 6, and this is going to occur at 7 pi over 6, right? Now, with this problem here, because it's like this, is it a half circle or even a quarter circle rotation? It's not, right? To get back to just to show you, if I was at this point, to get back to that point, I have to do a full circle to get back, right? So if I was going to add 2 pi every time, that would always get me to 5 pi over 6. Well, for the other one, for here, in order to get back to there, I also have to do a full circle rotation. So that one also has a 2 pi over 6, a 2 pi rotation to it. So I have to have 2 separate answers in this case, instead of like number 32 where it was just 1. So I'm going to do this. I'm going to get 4x is equal to 5 pi over 6 plus 2 pi, right? In fact, let me write it over. 4x is equal to 5 pi over 6 plus 2 pi. And then my other solution is going to be 4x is equal to 7 pi over 6 plus 2 pi. And then let's not forget the k. Are we okay with that? Okay. So then dividing by the 4, I'm going to get x is equal to 5 pi over 6 plus 2 pi k. That divided by 4 is going to give me x is equal to 5 pi over 24 plus pi k over 2. Are we okay with how I got that answer? We all right? And guys, you can use your mics to speak to me. You don't just have to type. You can unmute and be like, I don't understand this, and then mute yourself again. I actually would prefer that. That way we're still communicating with each other. Because from my perspective, it's like I'm just looking at a screen, you know? And so I encourage you guys to talk. Are you guys okay with this? Type it or say it. It's either way. I just want to make sure that you're okay. All right. Okay. Okay. Now, on the other side then, I'm going to do the same thing. So x is going to be 7 pi over 6 plus 2 pi k all over 4. So x is going to be 7 pi over 24 plus pi over 2k. And this is my other solution. We okay? One thing I wanted to also ask you, did you guys see that I posted up all of the notes, the completed notes? Okay, good. I'm also going to put all the blanks on there. I'll try to put those up tonight so you guys can have all of the completed notes up and available for you, so you can print them out whenever you want. And I'll put them all under notes, okay? Under the module weeks, I'll just put in the links to the Zooms by date, okay? And under the weeks, I'll also put in the video links. Does that make sense? Okay. Now our next example, number 33. Now, are we going to need a 2k pi or anything like that on this problem? Excuse me. Why do you guys think that? Notice in this example, we have a restriction there. So we're going from 0 to 2 pi. Do you guys see that? And since we're going from 0 to 2 pi, we do not need to do the 2k pi or... Sorry, I had to sneeze. Ooh, excuse me. So because we have this piece here, we won't need to do the repeating, please. Thank you. Okay, now to do this problem, then again, this is the angle that we're working with is the theta over 2. So we're going to simplify this, right? So 2 cosine of theta over 2 is going to be equal to radical 2. Cosine of theta over 2 is equal to radical 2 over 2. And now what we can do is we can go find this, right? So when we go to find it, here's the important piece to note. Where is pi over, where's radical 2 over 2 cosine? Isn't it right here at pi over 4? And it's also at 7 pi over 4, correct? Right? Those are the two spots. Now, something interesting that we need to look at, though. The angle that we have here when we're doing this, isn't it theta is from 0 to 2 pi, right? That's the period for cosine, correct? Okay, now that's true, but is our angle here theta? It isn't just theta, right? So our angle actually is theta over 2. And since it's theta over 2, I'm going to take everything and divide it by 2. Does that make sense? So what we end up having is 0 to theta over 2 has to be in this region, right? Oh, and I should have restricted. Sorry, not equal. Make this smaller so I don't have to delete everything. It can always be equal. We never include 2 pi, right? Because we don't want to repeat. Now, look at what happened there, right? So our theta over 2 was these two values. But when we look at the restriction, what does that tell us? Aren't we, if we're doing theta over 2, aren't we just doing half the circle? So which one is our answer? Isn't our answer only the pi over 4? Because when we do the full circle, it's both answers. But this restriction here tells us that we're only going to be looking at this region in our unit circle. And so it can only be that point right there. You guys okay with that? Okay. Let me go and do 37. So 37, we have cosine of 2x and we have sine of x. But do we want to have different trigonometric functions? Right? We don't want that. And since we don't want different trigonometric functions, I need to convert that cosine of 2x. So then I'm going to use cosine of 2x is equal to 1 minus 2 sine squared of x. So I'm going to get 1 minus 2 sine squared of x minus radical 2 sine of x is equal to 1. We okay with that? Now moving the 1 over, don't I get negative 2 sine squared of x minus radical 2 sine of x is equal to 0? And then multiplying both sides by negative 1, don't I get 2 sine squared of x plus radical 2 sine of x is equal to 0? And now what I can do is I can factor out a sine. So I'm going to get sine of x times 2 sine of x plus radical 2 is equal to 0. And now I have two equations, right? I'm going to have, all right, sine of x is equal to 0, or 2 sine of x plus radical 2 is equal to 0. So when is sine of x equal to 0? At 0 and pi. And since that's just a half circle rotation, can't I say then x is equal to pi times k? Right? Because I could go 0 plus pi times k, but I don't need to write 0, so I can just go pi times k, correct? Are you guys okay with that? Okay, then the other one, doing the manipulation, don't I end up with sine of x is equal to a negative radical 2 over 2? And so that one, I want to look at a unit circle. And so negative means it's going to be down here and down here, right? And this is 7 pi over 4, and this is 5 pi over 4. But those are not, I can't do clean rotations around, so I'm going to have two answers there, correct? So I'll try to write it here, and I'll write it in a different color so you can see it. So then x is equal to 5 pi over 4 plus 2 pi k, and x is equal to 7 pi over 4 plus 2 pi k. So how many answers do we have for this problem? The answer is really infinite, right? But it's three simple answers, and those answers are this one, and this one. Now, in this problem, we had to use the 2 pi k or pi k because the domain was not restricted. Does that make sense? So our domain was not restricted. So that's the big thing there. Yeah. So does that make sense to you guys? Okay. Let's do 39, and then I'll let you guys try to do 38, okay? So I'll do 39, and then I'll have you guys do 38. Okay. So one of the important things here is to note this here is a half angle, and so we can manipulate half angles. And so sine squared of x over 2 is equal to 1/2 1 minus cosine of x. So when I go to clean this up, I'm going to go 2 minus. I still have that 2, right? But sine squared is equal to 1/2 1 minus cosine of x. That's going to equal sine squared of x. Are we okay with that? Okay, good. Now, from here, I'll distribute, so I'm going to get 2 minus. It's going to become 1 plus cosine of x is equal to sine squared of x. But do I want them to have different trigonometric functions? Right? The answer is no. So I'm going to change the sine squared. So I'm going to get 2. Oh, let me actually start cleaning this up. Aren't I going to get 1 plus cosine of x is equal to, and I'll change the color so you guys can see I'm using the identity, 1 minus cosine squared of x. That's my sine squared piece. And then cleaning that up, the 1's will cancel. And I'm going to get, all right, cosine of x is equal to a negative cosine squared of x. But then I'm going to bring everything to one side. So I'm going to get cosine squared of x plus cosine of x is equal to 0. Factoring out a cosine of x, I should get this. And now I'm going to have two solutions, correct? So cosine of x is equal to 0, or cosine of x plus 1 is equal to 0. So when is cosine of x equal to 0? Doesn't it happen at 2 spots, right? So cosine of 0 happens at pi over 2 and at 3 pi over 2. And since that's half circle rotations, I can just say x is equal to pi over 2 plus k pi. And then here, I'm going to see cosine of x is equal to -1. Well, when does that happen? Well, again, if I look at my unit circle, rotate around, it's going to happen here. That's at pi, and it's the only place it happens. So it's full circle rotations around, correct? So then x is equal to pi plus 2 pi k. And those are my two solutions for this problem. Are we okay with that? So with the next example, don't you guys need to know, I'll give you a hint, don't you need to know what that is equal to in order to be able to break it down? So that's my hint to you. You'll attack it the same way in order to be able to solve this problem. I'll actually give you guys time to do this problem, and I'll work it out for you guys next time. But just so you guys have the rule, I'll give it to you. Isn't cosine squared of x over 2, that should equal 1 plus cosine of x over 2, or 1/2 1 plus cosine. Here, I'll write it that way. It's probably cleaner for you guys to see, so it looks the same. But these are rules that you guys should have memorized. 1/2 1 plus cosine of x. Okay? See if you guys can work that out. And then 40, I'll let you guys do also. I've already given you what that is equal to, right? That's this rule right here. So both of those I'll leave for you guys to work out, and I want you guys to try them on your own. And then what I'll do is I will post the notes and have them worked out for you guys, so you guys can have that. Okay, does that make sense? Yeah? Okay, just making sure. All right, I will stop the recording right here, because what I want to be able to do is give it to you guys in small chunks, so you guys have note 8 with note 8, and then when I go to notes 9, notes 9 will be there. But do you guys feel like you could do 38 and 40 based off the example I gave you on 39? All right, I'll stop this right here, and then I'll start a recording for notes 9.